Doing maths is looking a little different these days in some classrooms, as more collaborative approaches to solving mathematics problems are being encouraged. In some South Auckland schools in particular, this development of communities of mathematical inquiry is being led by Dr. Bobby Hunter, a researcher, academic and New Zealand-born Cook Islander, whose focus is on better meeting the needs of all students and of Pacifica learners in particular. The roles and responsibilities of teachers and students are changing as the patterns of communication and participation have students taking more responsibility for active listening and sense-making. In a lesson, the solutions to problems are discussed, negotiated and constructed in a collective way. Learning conversations include all students, and everyone feels that their contribution is valued. Students feel that everyone succeeds when the group succeeds. This video briefly explores the components of such a lesson. We'll look at the mathematics problems themselves, the way in which these are launched in the lesson before groups work together on constructing solutions. We'll see the collective sharing of these, and the way in which the teacher connects group learning to important big mathematical ideas. Finally, we'll identify the underlying communication and participation dynamics that are essential to a successful lesson. The problem itself is carefully chosen and crafted.
When I write a problem, my starting place is just what's happening in my room and the world of my students. I really think about the numbers I want my students to work with, and I make sure that the solution can be reached using a number of different strategies or approaches. They've got to be able to come at the problem in a number of ways.
The problems I write for the kids must be both achievable and sufficiently challenging, but I need to be really clear myself about the big idea I want to connect to. So knowing the number property that I want my kids to learn about is a useful starting place. Generalising is such an important part of mathematics learning.
As I create a problem, I've got to really know my students and know my maths. I know which strategies I want them to explore, but I also need to have anticipated ahead of time all the possible approaches the students might take. I also need to recognise possible errors they might make along the way, so I can use these to unpack the students' thinking and to take them forward.
We have heard how a problem should be culturally appropriate, be related to a current experience or context that is familiar, challenge the student's thinking, have multiple entry and exit points, be one in which a number of approaches or strategies can be used, lead to the big idea and generalization, be fully explored by the teacher before the lesson so that all outcomes and possible errors are anticipated. The kind of mathematics problems teachers give their students is really important. So are the cooperative and collaborative learning behaviours in the classroom. For everyone to be able to contribute their maths ideas to a collective solution and feel that their input is valued, teachers themselves must rethink their role and reconsider the power base in their classroom. Classroom behaviours and cues, attitudes and beliefs about what is important, and the implicit and explicit rules that govern the interactions in a lesson need to be talked about openly. Changing classroom norms and the way people communicate and participate take very careful scaffolding. And it takes time.
Okay, so now we're going to get started with our lesson. And before I ask you to think about what the expectation is when we're working in our groups. Can you show me this? Show me this that you've got an idea. Fantastic. Josiah, you popped your hand up. Active listening. What does that look like? Good girl. So we're revoicing to make sure that we understood or that we've listened correctly to the idea. So we've got active listening, we've got a bit of revoicing, which ties into active listening. Ezra, say that again. What makes a really good mathematician? Whisper it to me. Yeah. Asking lots of questions. Are we asking questions to be funny, or are we asking to try and understand their thinking? Yeah, absolutely. That's good. So we've got questioning, active listening. Unity. What kind of a learner are we today? What does that mean? If we're going to be a driver for our own learning, what does that mean? Liahana? Yeah. Being in charge of your learning? Yeah. Point to the person who's responsible. Point to the person who's going to help and guide you along the way. Excellent. So we're drivers and we're not going to be... Yeah, we're not going to go along for the ride, eh?
In order for each student to actively contribute to an agreed group solution for a given problem, all students need to understand what is being asked of them. They need to be given time to get to know and interpret the question. Giving class time to understanding the problem may involve the teacher in making time to wait for a student to clarify their thinking before they contribute their idea, echoing an interpretation to check for meaning, or asking a student to repeat what another student has said.
So, what's this problem asking us to think about right now? Big voice, please, Shania. So you've got how many cartons of milk are in the boxes? Cool. How many boxes do we have?
12.
12 boxes? Is that what it says there?
15 boxes.
And the first problem. Oh, thank you, Melly. 4 boxes. How many cartons of milk are in the boxes? 12. All right, so after that part, what else is there in there that's important?
How many milk sticks?
How many containers of milk, cartons of milk were drunk? Yeah. All right, so what we're going to do is we're going to act this out a little bit just to make sure that we all understand what's happening. So, Joe, can you stand up, please, darling? You're the milk delivery man, okay? What are you bringing into the classroom?
Milk.
Milk? How much milk? 4 boxes. And Katina, what's inside the boxes? 12 cartons of milk. So in each box we've got 12 cartons. So hand over 1 box to Katina. So what's Katina got?
12 One box with 12 cartons in it.
1 box with 12 cartons in it. Okay, hand another box to Melly, please. What's Melly got?
Another box of 12 cartons in.
Another box with 12 cartons. How many more boxes does Joe have to hand out? 2. Give another one.
Groups are comprised of students of a range of abilities. The onus on any student in the group is to ensure that all other group members understand the idea they have shared, and also to ask questions if they do not fully understand the idea of another student. All students must take responsibility for reasoned sense-making. As the teacher roves between groups, their focus is on the group process and dynamics. The teacher's role is to prompt individual and group responsibility for collective understanding of and negotiated agreement on a problem solution. It is not their role to simply give clues to find the right answer. The teacher may prompt the group to consider how they will support one of their members to present their agreed strategy and solution to the whole class. The group must also be prepared to answer questions and respond to challenges from class members and explain their mathematical reasoning. The teacher is also actively seeking the group whose strategies and solutions will, when shared, most effectively lead to new learning for the whole class. It takes astute noticing and sound mathematical knowledge of a well-constructed problem for the roving teacher to identify the group or groups whose solutions will best connect with the important big mathematical idea.
Okay, so which problem are you going to work on?
A.
You're going to work on A, and have you talked about how you might do that?
Yep. I've got it.
So you've got a strategy that you'd like to share with your group? Okay, fantastic. I'll leave you the pen. Valentine, can you explain this step to us? 46 what?
46 students from each 8 classes.
Class.
46
Yeah. you're going to figure out what it equals. And you added on there, Tumatila, what did you say?
From each classroom.
46 students from each classroom, fantastic. Now, is there 46 students in each classroom?
No, 23.
23. So what does 46 represent?
The 2 classrooms.
Do you both understand why Tumatila says 2 classrooms?
Because 125 because there are 8.
What could you do if you don't understand why she says it's 2 classrooms?
How can we say it's 2 classrooms?
Well done for listening for Tumatila's answer.
Because
It takes skillful orchestration on the part of the teacher to conduct the sharing session in which representations, explanations, reasoning and justification play a key part. As students explore and explain differences and similarities in approaches and representations, they revise and extend their thinking. The questioning and argumentation that the teacher encourages further deepens the understanding of all students.
Very impressed with the way you guys were working together, solving those problems, and I really like seeing some of the talk moves happening. We had people repeating in groups. Put your hand up if you repeated at some point. Okay, you repeated what somebody else said, fantastic. Put your hand up if you asked a question because you got a little bit stuck. Awesome. Okay, so when we're doing the sharing back part, you need to make sure that you still do those same things. If you are the sharer, once you've shared a little part, what do you need to do?
you have to put on the lid.
Put the lid back on the pen and ask what?
Questions.
Any questions? Then those of you that are listening, to show that you're listening, you need to make sure that you're doing what? Active listening, and then what will you do?
Ask questions.
You will ask a question and repeat. Okay. Fantastic. Any more questions?
Why did you choose the 2? To make it easier. Because we know what 8 times 10 is. 8 times 10. And then 10 is a tidy number, so it's easier to times with a tidy.
Okay, I'm just going to come back to that. Jordan, can you repeat what you said for us?
Because we know what 8 times 10 is.
Fantastic. Lindsay, can you repeat that?
8 times 10 is.
Great, so they know how to multiply by 10, and so you use that knowledge. Fantastic. And then Sarah Jane said that 10 is a tidy number. Who can explain to us what is a tidy number? What does she mean by that?
A tidy number is when there's a 0 at the end of a number, like 100 or there's 10s.
When the problem was being written, the important mathematical idea that this problem would lead to was clearly identified by the teacher. The nub of the lesson is at this point, when the teacher makes this connection explicit for the students and the important generalization is made. However, new reasoning may have emerged, and so the teacher also has to be ready to respond in the moment.
Isram, do you mind if I jump in, if that's okay? Hey, can we just say well done to the boys for their presentation? Okay, so if we look here, this part, you're going back to your question, Anushka, you said something about why did you use 20 and 20 and 1 and 1. So I'm going to hopefully use my strategy that might help to give some clarification as to why the boys have done it this way, okay? So let's see, we were trying to find half of 42. Now we saw that the boys knew for some reason to go 20 plus 20 and 1 plus 1, and then they put it all together and then they ended up with 21 and 21. With my strategy, I'm going to go 42 because I know with dealing with fractions we're trying to find what? When we deal with fractions we have to make sure that we have, yeah, we've got a whole, so our whole is 42, and we're actually going to split our 42 into equal parts. What does this relate to? Think about what we did right at the beginning. We talked about something. Whisper it to somebody. This here, we're drawing on our Family of facts knowledge.
Throughout the lesson, a finely tuned synthesis of participation and communication structures are at work to create a fully inclusive community of mathematics inquirers.
I've had to work at developing active listening with my kids and having them understand how important it is to ask questions if they don't understand. My message to the kids is really about actively taking responsibility for their own learning and for their classmates' learning as well.
It's taken time for my students to get the whole idea of supporting each other so that everyone understands and shares in the success of the group. It's a big shift to have them thinking about clearly communicating an idea so that everyone gets it.
I've worked hard to have the children understand and feel comfortable using mathematical language and terms. I've also had to work hard to clearly understand number properties myself so that I can write problems well and then make the connections for the children.
I'm really pleased that my kids are now learning to take a risk and will disagree or challenge someone if they're thinking differently. They've had to feel safe, and that takes time. We're now just starting to get some really good conversations about the mathematics in a problem, and it's really exciting.
In a classroom in which mathematical inquiry and learning is the responsibility of everyone in the class community, the teacher will often be heard to say to their students, "Remember, for a group to be successful, you all need to be asking a lot of questions." In fact, this deceptively simple reminder may disguise the complexity of the factors that the teacher has skillfully blended to create the safe, inclusive environment in which all the students can actively contribute to the collective success of mathematics.